Today we're going to be talking about domain and range of continuous graphs. We're going to start first with our vocabulary. The first one is a review word, a compound inequality. Remember, that's an inequality that's comprised of two inequalities together. A continuous function, when we're speaking about the graphs in particular, remember these are graphs that are unbroken. They can contain all types of values such as fractions as well as decimals. And then we have a new term called all real numbers. We use this phrase when our domain and range values are all possible real numbers, and we're going to use a special symbol, and that's going to look like an R, except we have two lines. Okay, so before we actually look at continuous graphs, we're going to start first with reviewing discrete graphs. If you remember for these, I can actually name all the points that I see on my graph. So I'm going to start here with 2, 1, 3, 4, 5, 6, 7, 5, and 9, 3. Now remember, for domain is focusing on just those x values. I'm going to write them least to greatest with commas in between. So I have a bracket, 2, 3, 5, 7, and 9. And then if I look at my range values, I'm looking at the y values. Again, least to greatest, commas in between. So I have 1, 3, 4, 5, and 6. Close my brackets. All right, let's look at example number 2. First thing I'm going to do is write out my ordered pairs. So I have 1 point at 1, 0. We have one at 2, 2. We have one at 3, 4. We have one at 4, 6. And we have one at 5, 8. So I'm going to look at my x values for my domain. Write my bracket, least to greatest. We have 1, 2, 3, 4, and 5. Close my bracket. In my range, I'm looking at those y values, least to greatest. I have 0, 2, 4, 6, and 8. Close my brackets. Okay, so now that we've reviewed those, we're going to look at continuous graphs. Now remember, these are unbroken data. So on this, the lines that connect the points on the graph are just basically a reminder that between the two whole number points, there's many possibilities of values. That could be decimals, that can be fractions, anything between those whole numbers. Because of that, it's impossible that we can list every single possible value. So instead, on this, we're going to use an inequality to show all the possible domain and range values. So let's look at example number 1, domain values. Remember, this is looking at my x values. So if I look at just this x-axis right here, you can see that I stop at the left at 1 and I continue forever to get bigger than 1. So my domain value is every number that is bigger than 1. Now, if you remember from a previous lesson, we talked about the fact that this is a closed circle. A closed circle means it could also be equal to. So I need my equal to bar. Okay, now we're going to look at our range. So our range is actually looking up and down. So now I'm looking at my y-axis. If you notice, or if you think about it, if I name every possible point on this line, every point that I see right here, this would be 1, 0, 2, 0, 3, 0. My line does not move up or down at all. It does not move along that y-axis at all. Every y value stays the same, and every y value is at 0. So y must equal 0. Let's look at another one. Number 2, I'm going to start first with my x-axis. So I'm looking left to right. You can see that it stops at x is 3, and then it goes to the left forever. So that means my domain is all x values that are less than or equal to, since it's a closed circle, 3. For my range, my y values, just like the first example, it's not going to move up and down along my y-axis at all. Every single point on this line is going to have the same y value, and that is a y value at 0. Okay, let's look at a couple more examples. Number 3 and 4. On number 3, again, I'm going to start with my domain. Now do you see that it actually stops on both the left and the right? So on the left-hand side, it stops at 1, 2, 3, 4. It stops right here at -4. And on the right-hand side, it stops at 2. This is going to be a compound inequality. We're going to have -4 and +2. And since I'm talking about domain, it's going to be x values that are in between there. At -4, we have a closed circle, so it has to be less than or equal to. And at 2, it's a closed circle, so it has to be less than or equal to. Remember, this must be least to greatest. So whenever I have a compound inequality, I will always be using less than signs. I will never use a greater than sign in a compound inequality. All right, let's look at range. All my y values, again, it doesn't move up or down at all. It stays at every single y value is the same, and it all has a y value of 0. So y must equal 0. That's the only possible value. All right, let's look at number 4. Now this one's a little bit different. My x values. So if I'm looking left to right, we can see every single x value on this graph has the same value. If I named this point right here, this would be a 0, 2. This would be a 0, 0. This would be a 0, -2. All of my x values are the same. It does not shift left or right at all. So all my x values equal 0. Now if I look at my range, it stops at the bottom at this y value of -2, and then it continues to rise forever. So we're going to say all my y values have to be bigger or equal to, since it's a closed circle, -2. Okay, number 5. If I look at my domain, again, my line does not shift left or right at all. Every single x value remains the same. Every single x value on this graph would have an x value of 0 and a number. So I'm just going to list a couple so you can see how they all have the same x value. So therefore my domain has to be x equals 0. I have no other possible x value. For my range, at the top, my y value, the highest y value I see is y value of 3. And then all my y values go down from there. So y has to be less than or equal to, since it's a closed circle, 3. All right, number 6, domain. Again, it's not shifting left or right at all. It's staying at every x value of 0. So x must equal 0. And for my range, the smallest number I see is at 1, 2, 3, 4 at -4. The highest number I see is +2. So this is a compound inequality. It stops on both sides. So again, I must write it least to greatest. So -4 to 2, I'm talking about range, so I must use the y variable. Both of them are closed circles, so both of them will be equal to, and remember, since we wrote them least to greatest, we must use a less than sign. All right, let's look at number 7 and 8. Domain, number 7. It stops on the right at +3, and then it continues forever to the left-hand side. So all my x values continue to get smaller. So x must be less than or equal to, since we have a closed circle, 3. For my range, it's not going to shift up or down at all. Every single y value on this is going to stay the same, and that is going to be a y value of 3. Think if I name all of these points, that would be -2, 3, that would be 0, 3, that would be 3, 3. Every y value has to be 3. All right, number 8, we're going to start seeing where it kind of changes for both. So domain, I'm going to look, where does it stop on the left and right? So it stops right here. That is an x value of -3. And it stops right here on the right, which is an x value of +3. So my x values go -3 to +3. And I use the x variable. Remember, it must always be a less than sign since we wrote them least to greatest. And they're both closed circles, so they'll both be equal to. For my range, I'm now looking at where does it stop at the bottom and the top. So this is a y value at -1 and a y value at +3. So now I have from -1 to +3. I'm talking about range, which is y values. Since I wrote least to greatest, it must be less than signs. And they're both closed circles, so they both must be equal to. All right, let's look at number 9 and 10. For number 9, domain, it does not shift left or right at all. It's a vertical line, so that means it must be x equals, and it's at the x value of -3. Again, every single one of these points would have an x value at -3. For range, do you see how it goes forever down and forever up? When I have an arrow in both directions, that is the perfect example of it never stops. It can go both directions forever. It can be any possible value. So remember, if it can be any possible value, we're going to use this funky looking R, and that means all real numbers. Y could be anything. All right, number 10. Again, it does not move left or right at all. It stays all at the same x value, which is x equals -3. For my range, it stops at the bottom at y is -2, and it goes forever up. So all my y values have to be bigger than that -2. So I'm going to say y has to be greater than or equal to, since we have a closed circle, -2. Number 11, looking at my domain. Remember, I'm looking from left to right, and if you look at the left and the right, you see that it continues forever in both directions. So that means my domain in this case can be any possible value. So I'm going to use my symbol for all real numbers. On this one, my range, it does not move up or down at all. I have a horizontal line. It stays steady along that y value, and that y value is -2. So all my y values must equal -2. Number 12. First, if I look at my domain left and right, this arrow means it's going to keep going to the left, and this arrow means it's going to keep going to the right. So my domain is all real numbers. Now, if I look at my range, the bottom to the top, the same thing happens. This is going to continue to go down, and this is going to continue to go up. So my range is also all real numbers. Anytime I have a line that is diagonal and it has arrows on both ends, both domain and range will always be all real numbers. Just like anytime I have a horizontal line like number 11 that has arrows on both sides, my domain will be all real numbers. And just like the previous page on number 10, if I have a vertical line that goes up and down, then with arrows on both ends, my range will always be all real numbers. Okay, let's look at number 13 and 14. So number 13, for domain, it stops on the right here at +3, and it goes forever to the left. Now, hopefully you can see that that is an open circle. So it's showing that all my x values have to be less than 3. It cannot be equal to. Remember, the open circle notes that it can't be equal to 3, but it's everything to the left of it. So it could be 2.99, but it can't be 3. For my range, my line does not move up and down at all. So all my y values stay the same at the y value right here of 3. So y must equal 3. Number 14, domain. It stops at the left right here at -4. And it stops at the right at +2. So we write at least to greatest. This is a compound inequality since it stops on both ends. I'm using my variable x since it's domain. Since it's a compound inequality, we know these have to be less than signs. And since they're both open circles, we will not have any equal to bar. For my range, my line does not move up and down at all. It stays along the x-axis, which is at the y value of 0. So y must equal 0. All right, number 15 and 16. Looking at number 15, domain. Domain, it does not shift left or right at all. Every single point on this line is going to have the same x value. So that means my x value is right here at -3. So all x values must equal -3. For my range, it stops at the bottom at y is -2, and it continues to go up forever. So all my values for y must be greater than -2. It is not equal to, since we have an open circle at -2. All right, number 16, looking domain and range, which is left to right, or domain, which is left to right. So we're going to say right here, it stops at the left at -3. Right here, it stops at the right at +3. So this is a compound inequality since it stops on both sides. I'm going to write at least to greatest. Since I'm talking about domain, I'm going to use the variable x. Since it's a compound inequality, since we wrote at least to greatest, they must be less than signs. Now, at -3, you can see it's a closed circle. So on the side where there's a -3, I need the equal to bar. However, if you look at the side where it has a 3, that is an open circle. So I will not have the equal to bar on that side. So in a compound inequality, you actually don't have to have matching inequality signs. One side could be equal to and the other doesn't have to be. For range, it's going to stop here at the bottom at -1, and it stops here at the top at +3. So again, least to greatest. I'm talking about range, so it must be my variable y. So they must be less than signs. We wrote them least to greatest. At -1, this is a closed circle. So at -1, it has the equal to bar. At +3, it's the open circle. So I do not have the equal to bar. Okay, now we're going to look at a couple that are not a straight line. These are parabolas, which are quadratic functions, which we're going to talk more about later on in this course. So let's start first with domain. It's going to stop at the left right here at -1, and it stops at the right at +3. So again, least to greatest. It's domain, so it must be my x value. Since they're least to greatest, they must be less than signs. And since they're both open circles, neither one has an equal to bar. Now for range, I am looking at the bottom, which is right here at -2, but then the top is up here at a point, but we don't really see a point. This is the highest point of the graph. That is at a y value of +2. So I'm still going to have a compound inequality, and I'm still going to write it least to greatest. Range is referring to y values. Since they're least to greatest, they're still both less than signs. Now, if I look at the y values of -2, you can see all I see are open circles. So at -2, it's going to be just a less than sign. There will be no equal to bar. But up here at the top, we didn't see a point at all. When you do not see a physical point, that is going to be considered closed. So that should have the equal to bar on it. Okay, let's look at another one. Number 2, it stops at the left right here. That is at value 1, 2, 3, 4, 5, -6. And it stops at the right at the y-axis. So that is when x is 0. So we're going to write it least to greatest. Domain is referring to my x values. I must use my less than signs since I wrote them least to greatest. Now at -6, you see the open circle. So on that side, it is not equal to. But at 0, it is a closed circle. So on the 0 side, I need the equal to bar. For range, it stops at the bottom right here at the y value of 1, 2, 3, -4. And it stops at the top right here at the y value of 1, 2, 3, 4, 5. Write it least to greatest, so -4 to +5. Domain is referring to y values. Remember, they must be less than signs since we wrote them least to greatest. At -4, I do not see a point at all. So remember, I told you that is considered closed, so it would have the equal to bar. At +5, now, if I look at these, I have 2 points that fall at the y value of 5. One is open, one is closed. So if that happens, the closed circle takes precedent. So that means it must be considered closed. All right, last 2. Number 3, this arrow tells me it's going to keep going left forever. And this arrow tells me it's going to keep going right forever. So if it goes in both directions forever, that means my x values can be anything, which means I'm going to use my all real numbers. For the range, it stops here at the bottom at y is -2. And then for the top, it's going to keep going up forever. That's what those arrows tell me. So that means y is going to be everything above -2. And since there is no point, remember that's considered closed, so that's going to be equal to. You can see that the very smallest number, the bottom of my graph, is at -2. So everything else has to be bigger than that. Now let's look at number 4. Domain is looking left to right. You can see these arrows. They tell me they keep going in both directions forever. So that means my domain is all real numbers. And for my range, it stops at the top right here at y is 3. And then these arrows tell me it keeps going down from that forever. So the highest value is y is 3. So that means all my other y values have to be less than or equal to, since we don't see a point, 3. This is one of those skills that needs a lot of practice for you to feel more comfortable with, but once you get the hang of it, it's going to be pretty simple. Okay, last two. These two examples are of what's called an exponential function. And again, just like the quadratic or the parabolas, we will talk about these later in the course. For now, we're just going to focus on the domain and range. And remember, we've been talking about domain is the farthest left to right. So the farthest left it goes is right here at 0. And the farthest right it goes is right here at 4. So my least is 0, my greatest is 4. And since I'm talking about domain, I know I'm using my x variables. Now remember, they should both be a less than sign because we wrote them least to greatest. Now if you look at the 0, we see an open circle, so that means it will not have the equal to bar. However, at the value of 4, it is closed, so we need an equal to bar at 4. Now let's talk about range. The bottom of my graph is right here at 1, and the top of my graph is right here at 4. So again, I write it least to greatest. Since I'm talking about range, I'm using my variable y. Remember, I wrote them least to greatest, so they should have less than signs. At 1, we had a closed circle, so it needs the equal to bar. But at 4, we had an open circle, so it does not. Okay, last problem, number 6. It stops on the left right here at -2. It stops on the right here at 1. Write them least to greatest. Since I'm talking about domain, I use my variable x. Since they're written least to greatest, I use less than signs. At -2 and at 1, they're both a closed circle, so they should both have an equal to bar. For the range, it stops right here at the bottom at 0.5. It stops here at the top at 4. Write them least to greatest. Since I'm talking about range, I'm talking about my variable y. They both have to be less than, since they're written least to greatest, and they both have to have an equal to bar since they're both closed circles.